graph the lines wrong, and then their whole problem's wrong. So you just got to be really careful and make sure you're graphing your lines correctly. And then we'll go back and hopefully this shouldn't be too bad if you follow my lead here. Okay. Oh, not plugged in. Really quick. So we're just going to start with just tons of examples here. First of all, a piecewise function just means you're graphing two or more different functions on the same graph. So if we graph a line and graph another line, we can do that, right? I mean, we graph them separately, so it's just putting them on the same picture, and then we're just going to erase certain values of that function. So you'll see what I mean. But we know how to do this because we know how to graph lines. So I'm going to first of all graph, so maybe do some notes here. We're going to graph y is equal to, so we have two functions. We have x plus 5 and we have negative 4. So let's just focus on graphing y equals x plus 5. That's our first step, is completely graphing that line. So remember, this is a y-intercept of positive 5 and a slope of 1 over 1. Correct, everybody? So our y-intercept, so go up 5, put your point, and then we're going up 1 over 1. And remember, we always go to the right. So this is rise and rise over run. And then remember, to start out, our run always goes that way. So up 1 over 1, draw in your line here. Down 1 over 1. And now we'll go this way, and our line should make sense here. So now draw that in. Okay, I'll give you a second to draw that in on your paper. I'm going to change colors. And now we're going to focus on graphing the next function. So we're now going to graph y is equal to negative 4. So think about what this is. X is changing, but y is always the same. If y always equals negative 4, we're going to go to negative 4 and start there. And then x can change, but y will always, oh, negative 4. That I just put a positive 4 on accident. So we're going down 4. So everybody, do you see how basically if this is 0x, I'm going to just rewrite like this, 0x minus 4. Isn't that the same thing as negative 4? 0x minus 4 is the same thing as negative 4, right? So let's graph this just like we graphed up here. We go down 4. Now we're going up 0. So we're literally going up 0, so we have a straight line with no slope. And once again, notice x is changing, but y is always at negative 4. See, look, over 1, down 4, over 2, down 4, over 3, down 4. Do you see how that's working? Okay, that's the hardest part, is graphing the lines correctly. Well, maybe one of the hardest parts. Okay, so now we all should have a highlighter. Grab one at least. Let me push pause and make. So now the next part is noticing your restrictions. Our restrictions are, we just have a restriction at negative 2. X is equal to negative 2. So you're going to find negative 2 and you're going to highlight negative 2. Okay. So now you're going to have a good eraser on your pencil too. So does everybody have a good eraser? Do I need to borrow some people an eraser on your pencil? Everybody good with their eraser? So pull up your eraser. So now we're going to focus on this piece right here. We're going to focus on this. Sorry. So we're keeping this function. Look back up here. The restriction was x values less than negative 2. So let's just focus on erasing this one, the blue line, or the line right here. So we're keeping this function for x values less than negative 2. Now notice the arrow is pointing that way, correct? We're going to keep that side of the highlighted line. Does everybody understand? So erase the other side. We're keeping this line for x values less than negative 2. So we're erasing, we're not keeping this side, we're keeping the underside that way of the highlighted line. Everybody good with that? So now we've done that part. Now let's look at this next one. It was y is equal to negative 4 for x values, I can't change here. For x values greater than or equal to negative 2. Notice my arrow's pointing that way. So we're keeping this side of the highlighted line. Erase the other side. So x values greater than negative 2 is what we're keeping, and we're erasing the other side. So go to your highlighted line at x equals negative 2. We're keeping that side of the highlighted line, so erase the underneath part. That's as good as it's gonna get. Yes. Yep. So that'll be our last thing we go back and fix, and then we'll probably do that next time at the beginning. Like we'll do it all together. So the last thing we've got to do here is notice how this one doesn't have an equal sign. That means it's not including -2. X equals -2 is not included. Since there's not an equal sign, and that was on the line, we've got to go back to the line. Here's our highlighted line at -2. We've got to put an open circle where that function is at -2. So that one has an open circle on the highlighted line because there was no equal to sign. And then this one has an equal to, so we just have a closed off dot. Because equal to fills it in, because that includes -2. So now we've graphed this piecewise function. Now here's one way to make sure, like here's a way to have a hint if you've done this right or wrong. This should pass the vertical line test. It should still be a function. So the vertical line test is this. If you take your pencil like this vertically and you go like this, and here's our function, the blue function, it never hits the function twice in one X spot. So so you look, it's still passing the vertical line test. It never hits my functions twice. So how we would have known we would have graphed this wrong, and a lot of times this will happen, is let's say that we unaccidentally erased the wrong side and we would have kept this side, for example. Now watch. We would know something's wrong because you see how right here, it's hitting the function in 2 places in one X value. It doesn't pass the vertical line test. Do you see how it's hitting my pencil up here and down here? That's how you know something went wrong. I've erased the wrong side on one or the other. Does that make sense? Okay, awesome. All right, so you guys have your function drawn. So let's do another one. Number 3. So focus on it in sections. Let's focus on graphing y equals -2x minus 4, and then we'll go back and restrict the values in a minute. So let's go graph that. So our y-intercept is -4, and our slope is -2 over 1. Rise over run. Honestly, graphing the correct line is the hardest part for people. So you go down 4, then you're going down to -2. So we're going down 2, and we always go to the right one to start out. So go down 1, 2 to the right one. Down 1, 2 to the right one. Down 1, 2 to the right one. And then now we'll go this way. Up 2, right 1. Go ahead and draw that in. Okay, so we'll draw in that line. Everybody good with that? Now let's draw in our other line. So now we're going to draw in y equals 4x minus 9. So our y-intercept is -9, and then our slope is 4 over 1. So go down 9. Then we're going up 4 over 1. So up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Something up there. Okay, drawing this in the best that I can. It's hard to make lines perfectly straight when drawing them by hand. So I've drawn in my 2 lines. I've done the hardest part. Now let's put in our highlighter. So our restriction is at x equals +2. So go to +2. That's right here. Highlight that value. Okay, let's focus on this piece. We're keeping this function for x values less than or equal to 2. So we're keeping this side of the highlighted line. That's what we're keeping. Now notice it's equal to, so isn't this going to be a solid circle? So we're keeping this side and erasing that side of the highlighted line. Now that was the blue line. You got to make sure you're doing the correct line. So we're going to keep this side over, and we're going to erase the bottom half. This side over. Everybody see how I did that? Now it gets at the highlighted piece at x equals 2. We're gonna keep it a solid circle. So I'm just gonna make sure I draw that in really nice and solid there so that Everybody knows that that's a solid line because it has the equal to. Now let's erase. So we're keeping this function. Now look back here for x values greater than 2. That's this side over is what we're keeping. So we're going to erase this side of the highlighted line for the red line. It's a little bit tricky on this huge smartboard. So we're keeping that side. We're erasing the other side. So it's kind of hard to get in there. In fact, I'm going to have to do that and then fix my blue just to make it pretty. And then that's what that looks like. Is everybody good? Your erasers are a little bit smaller than mine. Now, careful, it's not or equal to 2. X doesn't equal 2. It's just greater than 2. So we've got to have an open circle at x equals 2. Wherever your function is at 2, put an open circle there. Now let's make sure it passes the vertical line test. Yep, all good, all good. Never touched my pencil twice, all good. Still right here, it doesn't touch my pencil twice because solid circle and open circle. So we're all good, and then it passes the vertical line test. So we've done this correctly. Questions? So do you feel like it's as bad as I made it sound? Okay, good. Okay, so how about you guys try problems 2 and 5? Go slow, I'll come around and help you and whatnot, and then we'll do a little bit more advanced. So once again, same idea, we're going to focus in pieces. Now there's just 3 lines and 2 different restrictions, the exact same idea. So let's just focus on graphing y is equal to x minus 1. Y-intercept is -1, and our slope is 1 over 1. So -1, graph your line, guys. Drawing in your lines correctly, once again, tends to be the hardest part. Okay, we've graphed that. Now I'm wondering, I'm curious, I don't know, what do you guys think? Do you think it'd be easier here so we don't have so much going on to highlight and erase right now so there's not so much going on your graph? I think that might, let's try that, and then if it confuses you, we'll try something else. So let's highlight -2. So for that one, our restriction's -2, so go to -2 and highlight. I just think that sometimes there's so much going on, you kind of get confused on what's going on. Now we're keeping that function, so right now we're going to erase. We're keeping that function for x values that way. We're keeping, I'll say that again, we're keeping that side, erasing the other side for x values less than -2. So erase the other side, so we're keeping below and erasing above. So now, should we have a solid dot? Yep, let's draw that in too. So I'm just going to do it in red. Right there, at x equals -2, there's a solid dot. Now we just got to ignore that while we graph our next line so that we don't get confused. So let's move on to our next line. I'll do it in orange. So let's graph y is equal to 2x minus 1. So our y-intercept is -1 and our slope is 2. Ignore everything on the graph right now. So -1. Graph that. Gotta completely ignore everything. Okay, I'm gonna wait for everybody to get caught up to me with that drawing on your paper. Okay. So now notice in this one, our restrictions are, let's do our restrictions like we were just talking about. There's a restriction at -2 and 4. So we already have a highlighter at -2, but now we need to add a highlight over in at +4. Is anybody confused on that? So go to 4, put in your highlighter. Okay, now let's erase this correctly. This is the hardest one to erase correctly. But I'll be honest, if there's 2 restrictions, guys, it's going to bounce in the middle of them. Does that make sense? So you're going to keep in the middle in between. So notice how the arrow is pointing this way, we're keeping this side of 4. Does everybody see that? But then this is where a lot of people get confused because they think, oh, we're keeping this way too. But actually, x is, it's written backwards. So notice how usually x is written first. This is written backwards. So if we rewrote this, this is actually x is greater than or equal to -2. So we're actually keeping that way. Does that make sense? So you're basically keeping that way and that way of the highlighters. So erase everything else. So keep the inside of the highlighters and erase everything else. So I'm going over here, erasing the outside of the highlighter. And then I'm erasing the outside of the highlighter. Keeping in between the highlighters amount. Does that make sense? So we kept, if there's 2 restrictions, it will be in between the highlighted 2. Okay, now let's look and see where we need an open circle and closed circle. So on the highlight of, on the highlight of -2 on that orange function, we're not including -2. So you got to go to -2 on the highlighter, go to your orange function where it is at -2, put an open circle. Now look, there's a closed circle and an open circle. There will never be 2 closed circles in one spot, or else you'll have a problem. It won't be considered a function. Because that would be 2 x values for 1 y, 2 y values for 1 x value. So then look at this one. For 4, for the 4 part, it does include, so we've got to put a solid. So go to 4, go to your function, and put a solid. Yes. Because there's so much going on your graph, it's debatable because also erasing when everything's going on is hard. So now we're going to just have to leave everything, like ignore everything and focus on this piece. So we're graphing y is equal to -3x plus 8. So our y-intercept is at +8. Let's go up to 8. Now careful, this is -3 over 1. So we're going down 3 to the right 1. So down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1, down 1, 2, 3 to the right 1. Okay. Oh, okay, yes. I don't want, okay, so now we have our blue line. Now, I'm not going to draw that in until I'm only going to draw in what I need. So aren't we keeping that this side of 4? Look at the restriction for x values greater than 4. So we're keeping this side of the highlighted line. So that means we're only keeping this side. So then I just won't draw in the other side because then I don't have to erase. So I'm just going to erase the dots maybe. Oops, I'm going to fix my orange now. So hard to do it on the smartboard. So now look, oh, careful though. It's not including 4. So it's not including the x value of 4. So we've got an open circle. Now what gave me that hint that something was wrong is I saw this was a closed circle and I saw I had another closed circle on the highlighted line. And I'm like, you can't have 2 closed circles. So that was a lot more to think about. Do you think you can do it though? Yeah? Yes? Uh-huh. So we did have it at 8, and then we went down 3 over 1, down 3 over 1. So we just then erased. Does that make sense? Good question. And you could just draw them all in and then erase and everything. It's easier with a pencil. It's so hard for me with these huge erasers up here. I didn't draw it all in. So a little bit more going on. So try problem 6. See if you can do that. Answer those questions. So let's just quickly graph number 1. So these should go pretty quick here. We should be pretty good, better at graphing these. So I guess I do need to give you a second. Get your XY chart. Grab either the graphing paper I gave you or the already XY charts there, already given. Okay, so we're going to go up 5, correct? And then a slope of 1, focusing on this piece. So everybody graph that. So we'll be able to go a lot quicker. So I graphed that line. And then I'm going to erase accordingly. My restrictions at -2. Highlighter. We're keeping this side, it points this way. We're keeping that side, erasing this side. So I'm going to erase. And that one needs an open circle. the function at -2 needs an open circle. Everybody up there good? Now we have another function. We have -4. So that's this. That's 0x minus 4. So we're going down 4, and then there's 0 slope, 0x. So it looks like this. And then I'm erasing, we're keeping this side of the highlighter, erasing the other side. So we'll erase the underneath here, up to the highlighted x value, and that one is a closed circle. It passes the vertical line test, so I know I've done this correctly. Has everybody caught up to here? So that's the hardest part. Now let's evaluate the function. So it says what's f of, instead of x, look, f of x, then instead of an x, there's a 3. So x equals 3. So this is saying at x equals 3, what's my function at? So go to, here's my x values, guys. These are x values. Go to x equals 3. Isn't this 3? X equals 3. What's my function at? -4. Isn't that the value my function's at 3? So you would write -4. So it says, what's my function at -4? So at x equals -4, where is my function? At what value is my function? So go to x equals -4, find your function. Oh, my function's at 1 right there, correct? So everybody see how I'm doing that? So f of -4 is 1. That means my function at -4 is up at 1. Let's do -2. So that's x equals -2. What's my function at? So go to -2. What is my function at? Well, careful. Open circle means it's not there. So we have to go down to the closed circle. So my function's down at -4. Pretty straightforward. Okay. Questions on that? We're all good. Okay, sweet. Let's do this one. Or if you don't need another example, I won't make you have another example. I'll just cross out number 6. We won't do it. Do you feel like you can do those without me going over anymore? Because I don't want to waste your time. If you're good, let's just let you practice. Okay, cross out number 6, then I won't give you extra problems for knowing what you're doing. We'll just cross out number 6, but if you can do 2, 3, 4, and 5, then you can definitely do 6. So ready, set, go. The rest of the time is yours. You have like 30 minutes. See what you can get done.